The body repair trade, like any other skilled activity, has progressed steadily over the years in line with the advancement of vehicle body designs. Similarly, new tools and equipment have emerged to cope with modern requirements. New tools can mean new methods, which in turn can ensure the more efficient use of the time available for the job. The resulting increased throughput of work leads to higher profits and, more importantly, really satisfied customers. This program is intended to highlight the advantages of using some of the small tools and equipment currently available to the body repairer. These advantages have become apparent as a result of the research work done at Thatcham. Research a busy repairer wouldn't normally have time to do. A classic example is removing and replacing a rear quarter panel. This is one way of removing a rear quarter panel. One stroke too many with a hacksaw can lead to an unnecessary cut in the tailgate drain channel, needing more work later. This way of exposing the spot welds is effective but messy, and there's a real danger of fire. Toxic fumes can also prove to be a considerable health risk. The 1/8" drill acts as a guide for the 1/4" drill used to remove the spot welds. However, an ordinary 1/4" drill is difficult to control. Whilst this is an effective tool, it's very noisy and can create a lot of unnecessary damage. The repairer should wear both hand and ear protection. So the damaged panel is off. But was it the neatest and quickest way? There's damage that'll have to be repaired. Perhaps there's another method. This time he removes the bulk of the panel before tackling the spot welds. This works, but the heat and wrenching distorts the inner panel, and there's always the risk of the anti-corrosion wax catching fire. Both of these methods have left a lot to be done before the new panels can be fitted. The quarter-light aperture and the tailgate drain channel have both suffered with jagged edges and distortion. Now he's repaired the inner panel, he's not far off being able to offer up the new one. But it's taken quite a time to get there. Because access is limited, holes are required for welding, or in this case, brazing through. Incorrect gun procedures and previously repaired surfaces all contribute to poor spot welds. The oxyacetylene welding is causing a great deal of heat travel in this area. Working with lead requires one to wear a proper face mask and protective gloves. Lead is very poisonous. If he were to eat lunch with his hands in this state, he'd expose himself to further risk. And the sander is throwing fine lead particles into the air all around him. They're hard to see, but they're there. These matters are thoroughly covered in the Health and Safety Executive's approved code of practice. So that's this panel finished, but the painter wouldn't accept it with the distortions caused by the gas plug brazing. And these spot welds leave something to be desired. Let's see how he's doing on the other side. Here he's edge welding around the quarter light and brazing the tailgate. As an alternative to lead, he's using body filler on this side. It's been a long job to this point, and there's still more to do on both sides. But how much extra effort has been needed, and how about the work still to be done by the painters? This one for sure has a weak point or two. And here's a perfect corrosion trap with that brazing. It's not that the work you've seen is all that bad. It's the methods, and in particular the tools that dictate those methods, which are open to question. It's for this reason that the Motor Insurance Repair Research Centre at Thatcham spends so much time appraising the different methods and techniques that can be adopted by repairers faced with the problem of replacing damaged panels. But there is a way you can set about a similar repair, and with a guarantee of success. Any repairer involved in extensive work on damaged motorcars needs to have certain tools and equipment, without which he'll find difficulty carrying out work to the required standard. A jig is indispensable. Without it, a structurally damaged body can't be accurately measured and realigned. A MIG welder is essential to guarantee quick, accurate welding of panels with reduced heat and distortion problems that are inherent in using a gas welder. With extensive use of spot welding by most manufacturers, suitable equipment for this type of work is also a must. The interior and glass should always be protected, and so should you. Removal of damaged panels and part panels implies the use of certain specific hand tools that have been carefully designed for the job. To remove this quarter panel, You should first reveal the spot welds with a rotary wire brush. The one being used here is impregnated with plastic to help prevent the wires from flaying over. After center punching, the spot welds can be removed using a spot weld cutter. This is a clean, efficient tool. You should adjust the center point of the cutter so it only cuts through the first thickness of metal. If using a cobalt cutter, there's no need for center punching or weld nugget removal. Likewise, this one, which drills to a preset depth, needs no center punching or nugget removal. The pillars can now be cut through. Using an air saw, a clean cut can be produced quickly. This is a very powerful tool, and it's particularly useful in confined spaces as the blade has a very short stroke. Make the cut so that an overlap is left to assist in fitting the new panel. If you used a spot weld cutter, after separating the panel with a bolster chisel, the weld nuggets are revealed, and these should be cleaned off with a sander. Providing the removal of the old panel was done correctly, fitting the new one should present no problems. But before you even offer up the panel, prepare the edges on both the new and existing panels. Start by using a disc sander to remove the coarser material and finish off with a rotary wire brush. The improved finish at this stage speaks for itself. After checking the gaps are correct, cut through the new and existing panels where welding is to take place at the pillars using an air saw. By cutting through both surfaces together, a neat butt joint is assured. Where possible, punch rather than drill holes ready for MIG plugging. It's quicker and cleaner. The prepared bare metal surfaces should be covered with a zinc-rich spot weld primer to prevent oxidization. After checking the gaps are correct, the MIG welder is now used on the butt joints, which should first be tacked and then sanded. Continuous welding can now be done. There are many types of MIG welder on the market, including some with a pulse arc facility. One of the principal advantages of MIG welding over gas welding is the reduced heat travel, which minimizes the risk of distortion. Before using the spot welder, the tips should be dressed. After adjusting the arms and setting the machine, carry out a test weld. The pulled slug indicates a correct setting. There's a wide range of arms available for the spot welder, including the set used here for easy access to the wheel arch. Where holes have been punched, MIG plugging is to be preferred, as there's no access for spot welding. After cleaning off the MIG welds with a disc sander and rotary wire brush, the joints should be soldered using a propane torch. This torch dissipates its heat over a wide area compared to an oxyacetylene torch. This does much to reduce the risk of heat distortion to the panel. When tinning or soldering, be sure to wear the special fresh air-fed face mask. Use a body file rather than a sander to clean off the excess solder. The blade is designed to avoid clogging. Finally, smooth off the butt joints with a random orbit sander, which has a dust extracting facility. Any painter will accept this job. The advantage of this approach, the advantage of using the right tools and equipment, is that the work is completed to the highest possible standards in the most efficient, safe and profitable way. The tools and equipment, the working practices that have been shown in the second part of this video, are all recommendations that result from extensive work carried out by Thatcher. A comprehensive list of small tools that a car repairer requires includes the disc sander, the rotary wire brush, spot weld removers, the hole punch, the air saw, the orbital sander with dust extraction, band sanders, a spot weld tip dresser, and health and safety apparel. All these are fully detailed in the Thatcher Methods Manual and the accompanying equipment lists, which form a desirable foundation for any repairer's business.